We'll wait for 2 more minutes, maybe 5 minutes, for all to arrive. Okay, let us start. We have discussed encapsulation and inheritance yesterday. We're going to discuss polymorphism and exception handling today. Actually, both the topics are oceans. So all the features are not required to everybody. We will discuss to the extent required for developing a project. Let us write a function, a method which is static, returns nothing. Say function name is volume. Function name is volume. Okay. It takes say one input, that is length. It calculates volume. Let us take length also as double, because we can, then we have liberty to enter any value, is equal to length of a cube is given. So length into length into length, okay, is a volume. So let us print the output. Volume of a cube with length centimeters is say centimeter cube or cubic centimeters, okay. And you need to put dollar here. So volume of cube with length so many centimeters is this much, okay. Is this clear? Now this will calculate, and this will calculate the volume. Let us find volume. Say name of the function is volume. Say input is 10 or 10.5. Okay. And let us execute this. The function must have a return type, returning a double. Returning a double. Let us run it. Static double volume. So not returning anything, I'm sorry. We are printing the output here. This is void. The solution is 11.7. Volume of cube with length 10.5 centimeters is 11.57.625. Okay. I want to round it. I don't want digits after decimal point. I think round is in math. Okay. Now I want to find out volume of a rectangular box also. I want to find out volume of rectangular box also. Instead of using a different function name, I use the same name. There are three inputs: length, width, and height. Function name is same. In the first function, there is only one argument. The second function, there are two or three arguments. Function name is same, but arguments are changing. There are three arguments now. Okay. Now let us find out volume. What is volume? Volume is length into width into height. Okay. Now let us print volume. console.writeLine. Now length is equal to volume of rectangular box with length is equal to length, okay, comma, width is equal to width and height is equal to height is, okay. So this is a formatted output, right? Let us have everything in one line. Why all this? Let us simply print. Okay. Here also volume of a cube is, okay. Next, let us have one more function with same name, static void volume double radius, okay, comma, double height. Now volume is equal to pi r square h, pi radius into height. Now print volume of cylinder. Volume of cylinder. So this is polymorphism. One of the concepts of polymorphism. We have same function volume with one parameter, with three parameters, and with two parameters. Okay. So face is same. Face is same, but it behaves differently when different inputs are given. So double, let us straight away give the values. So volume, give one input, say 10.5. Next, call volume with three inputs, say 10.5, 9.5, say 2.6. Call the volume, this time for cylinder. Radius is 5, okay, height is 10, right? Is this clear? Do you understand it? Mr. Prithvi, what is 77 equal to y? Okay, let us run this. There are some semicolons missing. Okay, one additional double quote here. Here also one additional double quote. Okay, everything I think is taken care of. Okay, so you can see the output. One input is given, then first function is executed. When three inputs are given, second function. When two inputs are given, third function. So I hope you understand it. Okay, same function. I did not write different functions. Maybe say cube volume, box volume, and cylinder volume. Okay, so I did not use three different ones. Say cube, box, and cylinder. Okay, I used a single name. Sorry, the name should be given here. Cube volume, box volume, cylinder volume. Okay, so instead of giving three names, what we can do is we can give a single name, but difference is shown in the arguments. Difference is shown in arguments. One argument in first call, two arguments in second call, three arguments in third call. Okay, so you get the same output. So I hope you understand it. Is this clear? Next, same method, behaves differently when different arguments or inputs are given. Okay, are given. They may differ in type and number. Okay, next, let us understand what is virtual and what is override. Before going to that, we should know one important concept. Suppose there is a class by name guardian. Okay, now there is a class by name parent derived from guardian. There is one more class uncle derived from guardian. Okay, now you can create instances of parent and uncle. Okay, in two different ways. One is One is parent. Say this is object is equal to new parent. Okay. The other way is parent is a guardian. Guardian parent. Okay. Belongs to parent class. You can create in these two ways. Similarly, guardian uncle of uncle class. Okay, so both types are okay. Fine. So let us take an interesting example to understand this. Let us remove all these classes, all these methods. We have only one method in this class. Let us create one more class student. Okay, we have a function here which returns nothing. Name is function. The function of student is attending institute regularly. Okay, now there is one more class, say boy, derived from student. Boy derived from student. It too has the same function. Public returns nothing. Function name is function. Okay. In this case, it prints, say attending school, because it is a boy attending school regularly. Okay. Next, let us create one more class. This time, teen, derived from student. Student is base class. Now, the method is same. Public void function. Okay. Public void function. This is a function with no parameters. Fine. Now, what a teenager does, goes to upper primary school or goes to a junior college, attending junior college. Okay, regularly, right? Now, let us create a student boy of boy type. Okay, Let us create a student teen of teen type. Okay. Create a student boy of boy type. Create a student teen of teen type. A teenager. So why no response here? Please do respond. How can I know that you are following it or not? So please do respond. I know that there is some time lag, but I expect some response from you. Please respond. It cannot be a one-way teaching. Otherwise, I feel that I am teaching to a wall. Okay. Bhargav, it is fine. What about others? Very good. So it seems at least some of you are listening. Okay. Now, call. So also create a student of student type. Also create a student of student type. Okay. This is base class object and this is derived class object. Base class object and derived class object. Okay. Now call function from base class. Call function from boy class, from boy object. Call function from boy object and call function from teen object. The function is same, but content is function name is same, but content is different. Okay, is this clear? There are three classes, three objects. Boy and teen are derived from student. A function is written in all the three classes with same name. Let us see what happens. So what happened? Leave about warnings. See the output. Okay. So which function is implemented? Which function is implemented? The function written in base class is implemented. Is this clear? It prevailed on other two functions. Though you called function from boy object and function from teen object, you got the function written in base class. Okay, is this clear? Did you understand it? Did you understand it? Okay. To avoid this, what I do is I make the function in the base class a virtual function for its derived classes, and this overrides the base class function. This overrides the base class function. Okay. Now base function function written in base class is virtual, right? So let us see what happens now. So what happened? The virtual object is not implemented. What is implemented? The function in boy object and the function in teen object are implemented now because they override the function in the base class. Okay, is this clear? So you can control the execution or you can override the same function in the base class. Okay, if it is improvement over the base class one. Hope you understand it. Is this clear? Say no warnings, no errors. Now suppose this is not virtual. You are not overriding. Here also you are not overriding. Okay, here you create boy object from boy class, teen object of teen class. Okay, now let us implement it. You get the result. You get the desired result, but with a lot of warnings. Okay. So this is base class method. This is derived class method. This is another derived class method. Let's see the warnings. Okay, to avoid it, you better make it a virtual function. Okay, better override that with override identifier. Now run this and see. Right? Is this clear? No warnings. Or you can do like this also, as I told you. Student boy of boy type, student teen of teen type. So I hope you understand it. Okay, now this is about polymorphism. Let us not go in detail about the terminology. Okay, what is overriding, what is overloading, we discuss about them later. Okay, in the meantime, try to understand the concept. Okay, polymorphism, same function with different behaviors, same phase with different behaviors and different contexts. Okay, so I hope this is clear. Let us go to next topic of the day. So we have seen now what is virtual, how does it work, and what is override. Okay, a virtual method of base class can be overridden by derived class. Okay, next concept of the day, exception handling. So look at this. This is a Python editor. I will increase the size. Don't worry about it. If I divide something by 0, what happens? If I multiply, divide, what happened? You got some error. Okay, is this clear? And program stopped, and your program stopped. Okay, assume that you are operating ATM. You inserted your card. Okay, so something went wrong. Something went wrong. Okay, the program got stuck. The program got stuck, and your card got stuck. If something goes wrong, the program stops. The program stops, and you cannot remove your card. You cannot remove your card because the ATM doesn't know what to do when program goes wrong. You inserted your card, something went wrong in the program. Okay, maybe you are trying to draw more money than you have, right? You are trying to draw more money than you have, and no instruction is written for that, so program stopped. Or you entered invalid pin. Okay, the program stopped, and you cannot remove your card, so this will stop the entire process. Not only your transaction is struck, but others also cannot use it. So in this case, the system should stop the process, stop your process, or kill your process. Okay, and other processes that follow should continue. Other processes that follow should continue. Is this clear? It should not stop forever. Errors do occur. Okay, exceptions do occur. The system should handle those errors or exceptions. Hope you understand it. It should tell what happened. It should tell you what went wrong. The system should tell you what went wrong, and life should continue. Should tell you what went wrong. Okay, and should continue with the remaining process. Should continue with the remaining process. Do you understand it? Okay, but this is done like crisis management using exception handling in almost all OOPS languages, using try, catch. Okay, these are must blocks, and optional blocks are finally and through. So using these blocks, exceptions are handled. Okay. So please do respond. The chat box is meant for that. Okay. Say A equal to 10. A equal to say B by C. Nothing may go wrong here. Okay. Say int A equal to 10. Now here it may stop the process. It may stop the process. Okay. If C is 0, it may stop the process if C is 0. That is, statements like this are susceptible are prone to problems, prone to errors. Okay, is this clear? Say statement like just printing something, so there's no problem here. Okay, so this statement may not go wrong, but this statement may go wrong. The statements that may go wrong that may stop the process are put in try block. Okay. If they cause any damage, that damage is caught by catch block. It also tells nature of damage. Okay, next, finally block. Okay, we'll continue the process as if nothing had happened earlier. Okay, is this clear? Okay, let us see an example and try to understand it. Say, whoever are attending, please do respond. It's not possible for a teacher to teach to a wall. Okay? It's not a mono action. What about others? Only Bhargav is responding. See, I cannot continue without your response. I must know the feedback. Say, Prithvi, Pavani, Vipula, where are you? Why are you not responding? Let us read A using console.readline. It reads a string. Let us parse it into an integer. This is how you convert. You can convert using convert statement also, but this is a different way of doing it. P must be capital. Also read B and parse it to integer. See what happened to other students? Why are not they responding? Am I audible? So why don't you respond then if everything is fine? So dear students, please do respond. It cannot be a solo performance. I cannot continue like this. Sudhir, I can see your response. What about others? And let us create one more variable C, but default value is 0. Now find out C as A by B. C is A divided by B. Okay, because this is prone to error, I put this in try block. Okay, is this clear? This is susceptible to error. If B is 0, it could become infinite, and infinite cannot be handled by computer. Now that problem is caught by catch block. Okay, the type of error is, if you know, you put it. If you don't know, leave it to system. Suppose you know it. This is a standard exception, standard message. Divide by 0. Okay, and this is divide by 0 exception. Divide by 0 exception. EXCEPTION. Okay, this is a class itself. The class object is E. Now here you print. It tells what happened. So this is for us. Say exception is caught. And what is the exception? That is E. Okay. Now, so tell what to do if there is error or if there is no error. Print the values of A, and this is a different way of printing, formatted printing. Print B and print C also. Okay, first you print A, then print B, and then print C. Okay, now here the main method ends and here the class ends. Now let us run it. Let us give inputs in input block. Let A is 20 and B is 10. Okay, so no problem here. If there is no problem, we do not enter into catch block. We directly go to finally block. Catch block will catch if there is any error. Okay, is this clear? No error, and you get the values 20, 10 and 2. Let us see if A is 20 and B is 10. The exception is caught. Okay, whatever you typed here, exception is caught, and the error is divide by 0. Okay, if you don't use exception, the program stops there, but here it gave you default value of C, so it regained the original position. The card you inserted came back so that others can use it. The program did not stop. Okay, now here I write some statement. Say console dot write line. Okay, say the process continues. The process continues. Okay. Inputs are 20 and 0. And the process continues. Okay. Is this clear? Now, let us see a program without exception handling. Without exception handling. Okay. Let C is equal to A by B and print okay, print A, print B and print C. So first A and then B and then C. Okay. Now see what happens. What happened? The program stopped. It did not come to console.writeLine statement. The program stopped here itself. Abrupt stoppage of program. Okay. Is this clear? So the card you inserted in ATM machine got stuck and is not coming back. It got stuck there. To avoid that, you need crisis management. That is exception handling. Put this in try block. Okay. So C equal to A by B. If there is any error, that error is caught. Okay. Now, in this case, you don't know what is the problem. You simply mention exception. Okay. You don't know what happened. Spelling is EXEPTION. Okay. Now here, print okay, something went wrong. You don't know what it is, but it tells you that something went wrong. Okay. Now, finally, we'll tell what to do. Here you print the default values. Okay. Now, if you use dollar, in different ball game. Okay. A equal to A, B equal to yes, exception is a class. That's why you created an instance. C is equal to C. Okay. Right. Now let us implement it. What happened? C equal to A by B, try, catch, exception, console dot Acha. So end of class is missing. Okay. What happened? It told you that something went wrong. Okay. If you want to know what went wrong, then print now print the message parameter of the exception. Okay, it tells you what went wrong. Attempted to divide by 0. Is this clear? Is this clear? Now, before I sign off, I would like to explain you one more thing. Let us create an array. Okay, of integer type. Say of size 5. Of size 5. Okay, this is initializing every element of the array with 0. Now, try to print let us remove it. Okay, let us do some more thing here. Say console dot write line, say process continues. Okay, now here I try to print 6th element or 5th element. What is the maximum index? What is the maximum index? 0 to 4. But there is no 5th element, but I am trying to print it. Okay, let us see what happens. No inputs here. Taking a bit long. So let us remove these values. Okay, and try to run the program. So what happened? Index was outside the bounds of the array. Index was outside the bounds of array, and the process is continuing. Okay. Now let us try to print 4th element of the array. Okay. A 4th element is there, so you don't encounter any problem. Okay. Value is 0. If there is no exception handling, okay, you have an array of size. You have an array, say of size 10. Okay, and you like to access 10th element. You have elements up to 9. Okay, here you type say console dot, okay, so print something, say something went wrong, okay, continue. Let us see what happens. What happened? It stopped abruptly here itself. It doesn't come to a statement below it. Okay, So this is the use of exception handling. We will learn much more about it in the next class. In the meanwhile, so please practice these examples and some more. The topics covered are polymorphism and exception handling. Okay, very important concepts of OOPS, right? So if you know C#.NET, then you have a powerful tool in your hand. A powerful tool in your hands to develop desktop, mobile, and web applications. Okay, you can develop desktop application, mobile application, and web applications. That too, interactive ones. Okay, and the day is not very far to learn all these three. Okay, so thank you, and I sign off. We will meet on Monday. No class tomorrow. Okay, so thank you.